is our first lecture of BSc Physics first sem syllabus, and the first chapter is Basic Concepts of Classical Mechanics. Today we will deal with classical mechanics and what is mechanics of a particle, how force work on particle, what changes will be there when a force is applied on a particle. Let us start what is classical mechanics. Here we are dealing with classical mechanics, the basic concepts of classical mechanics. Classical mechanics is that branch of physics which deals with not very small particles. It means we are not studying atom and molecules here, and not very large particle or macroscopic particles. It means we are not dealing with microscopic particles, the subatomic particles, and we are not dealing with large size particle, that is macroscopic particles. And also there is a one condition: the motion of the particle or the velocity of the particle should not be equal to the speed of light, that is not equal to c. It means the particles are moving with small velocity, and that velocity is not equal to and not approximately equal to the speed of light. This is the classical mechanics. Classical mechanics, it is the branch of physics which deals with the study of not very small particle, not very large particle, and the particles which are not moving with the velocity of light. If we are dealing with microscopic particles, or we are dealing with subatomic particles like electron, proton, neutron, their motion, their masses, it means we are studying quantum mechanics. And if we are dealing with the particles which are moving with approximately the speed of light, it means we are dealing with a branch of physics that is known as relativity. The classical mechanics, it is divided into three subsection, that is into three parts. One is known as kinematics, which you already studied in your 11th class. It is the branch of classical mechanics which deals with the particle which are in motion, but the cause of the motion is not known. We not know what type of forces are causing that motion. It means there is motion of the particle, but the cause is not known. The cause or the forces behind the motion is not known. Forces are not known. We only say that the particle is moving with the velocity v, having an acceleration a, but the cause of the motion is not known in case of kinematics. Second branch of the classical mechanics is dynamics. In case of dynamics, the particle or the system is in motion and the cause behind the motion is known. What type of forces are associated with the motion? Here we know why the particle or why the system is in motion. It means the dynamics, it is the branch of classical mechanics in which the particle or the system is in motion, and cause of motion or the forces behind the motion are known. The third branch of the classical mechanics is statistics. What is statics? It is again the study of that motion where total net force on the particle is or the on the system is zero, hence due to which the motion or the system is in rest and there is no resulting motion, as the total net forces on the system is zero. It means the statics, it is the branch of the physics where net force on the particles or on the system is 0, hence the system is in rest or the system is in no motion. Here there are three branches. One is kinematics, where the system and the particle are in motion but the cause behind the motion is not known. The second is dynamics. The again the system is in motion, the particle is in motion, but the cause behind the motion is now known. In the third branch or in the third type of classical mechanics, that is statics, the total net forces on the particle or the system is zero, hence the system is in rest or system is in no motion. Now we will study about the mechanics of a particle. In mechanics of a particle, we deal with many physical quantities, as the title of our discussion is showing, that is mechanics of a particle. It means we are dealing with motion of the particle. If the particle is in motion, there are many physical quantities which are behind it. Now we will discuss the mechanics of a particle. It means we have to discuss about its velocity, the force behind the velocity or the motion, what is the momentum, and when the force is applied, how there is a change in momentum and how there is a change in acceleration and there is a change in velocity of the particle. Let us start with velocity. How we will find out velocity of a particle if the particle is in motion. Let us consider the particle is moving in xy plane. There are it is a two-dimensional motion, and at any time t the particle is point A, and after time t dash the particle is at point B, and when the particle is at A, let the position vector of the particle is r1, and at position B let the position vector of the particle is r2. Then what is the displacement if the particle moves from A to B? Then the displacement vector is given by r2 minus r1. Then how we will give the velocity of the particle? The velocity of the particle is given by r2 minus r1, that is divided by t dash minus t. We can give the velocity of the particle like this, but the condition is that here the limit change of time that tends to 0. It means this gap and this displacement is very small, such that the time taken from point A or position A to position B is approximately equal to 0. Hence the velocity is given by the differentiation of the displacement vector with respect to time. This is our velocity, the displacement divided by the time taken. We very well know the velocity, it is a physical quantity and it is measured in SI unit, and the SI unit is here meter per second. Next physical quantity which is connected with the mechanics of the particle, that is linear momentum. If the particle or the system which we are considering that is moving from A to B have mass m, then what will be the linear momentum? The linear momentum, it is indicated by p, and it is a vector quantity, and the linear momentum, it is in the direction of velocity. Linear momentum, it is the study of motion of the particle, and it is calculated by the formula p is equal to mass into velocity. As m is a scalar quantity, it means p is in the direction of the velocity vector. Next is the momentum, which was first introduced by the Newton, and in Newton's second law we discuss about the relation in between the applied force and the momentum. If a particle is in motion, if there is a change in momentum, then second law tells about the relation in between force and momentum. When the external force is applied, there is a change in momentum, that is change in motion of the particle, and it is given by F is equal to rate of change of momentum or change in momentum in unit second, that is defined force. If F is equal to dp upon dt, and from above relation we put p is equal to mass into velocity, we will have time differentiation with of mass into velocity. As we know that mass remains constant with respect to time, it means there is a change in velocity with respect to time, and change in velocity with time, that is known as acceleration. It means we can write the above result as mass into acceleration, where acceleration is a vector quantity and acceleration is given as rate of change of velocity with respect to time period. The direction of acceleration is the direction of change in the velocity. If we consider the particle again in two dimension, and this is the direction of velocity at any position A, and this is the direction of velocity of the particle at any position B, then we have to find out the change in direction of velocity v1 to v2, and that direction is the direction of acceleration. In our case, if we closed this figure, we find out this is a triangle quantity, and this velocity v2, it is in anti-clockwise orientation or direction, and this quantity v1, it is in clockwise direction. If we make v1 in anti-clockwise direction, then we have to write this with minus sign. Now it will become in anti-clockwise direction, and according to triangle law of vector addition, the closing side, that is from B to A, that is in clockwise direction, that will give the resultant of the two vectors v2 and v1, and it is given by here v2 minus v1. If body is moving from A to B, then this result from A to B will become v1 minus v2, and v1 minus v2, direction of v1 minus v2 is this from A to B. If this is the direction of change in the velocity, this is the direction of our acceleration. Hence, we can easily find out the direction of acceleration if we know the initial velocity and final velocity of the particle. On substituting v is equal to dr upon dt in the above equation, we get acceleration A is equal to d square r upon dt square. And if we substitute this value of acceleration in the above value of the force or in the above equation, we will get F is equal to m d square r upon dt square, that is second order differentiation of displacement vector. This is known as equation of motion of the given particle. It means if a particle is having mass m, At any position A, its position vector is r1, and at any time t dash, its position vector is r2, and it is moving with velocity v1 at initial position A and with velocity v2 at final position P, then its equation of motion is given by F is equal to m d square r upon dt square. Next we have some another physical quantities which we will find out when the particle is in circular motion, or it is in rotational motion, or it is in angular motion, and that quantity is known as angular momentum. Angular momentum, it is a physical quantity which gives the motion of linear momentum, and we very well know that linear momentum is mass into velocity. Then angular momentum L is given by the radial vector cross with the linear momentum. Let us consider a particle is moving in anti-clockwise direction and the circular path have a radial vector r, and at any position A the velocity of the particle is v, and we know that in the direction of v, if the particle has mass m, in the direction of v there is a momentum, and the momentum is given in is equal to mass into velocity. The at point B, the let us consider the particle is moving with a constant angular velocity, then the magnitude of v is not changing, but the direction of v is changing. Now the direction of v is this. It means the momentum is also changing. The motion of this momentum is known as angular momentum. Here the momentum P is become again m into v, but now the direction is this. The study of this motion of angular momentum is known motion of linear momentum is known as angular momentum, and it is the cross product of radial vector and linear momentum. We can't change the order, we can't write this like this. L is equal to P cross R, because P cross R or a cross product is anti-commutative, means R cross P is not equal to P cross R. R cross P, that is the cross product of two physical quantities or two vectors, are not and are not commutative, they are anti-commutative. It means they can be written as R cross P, can be written as P cross R, but with a negative sign. Then in case of angular momentum, how we will give the direction of angular momentum, we can curl our fingers of right hand side from R to P, then the thumb of our right hand we give the direction of L. In our case the linear momentum is in this direction. At any point we can at any point A, the direction of our linear momentum is this, and this is the direction of our radial vector. Then we can curl our fingers from R to P, then this is the case, this is the direction of R and this is the direction of P. Then we can curl our fingers from R to P, that will be in the anti-clockwise direction, and the thumb will be in outward direction. It means the in our case the angular momentum is coming out of the plane page. This is the direction of angular momentum. And the SI unit of angular momentum we can easily find out from our relation L is equal to R cross P. L can be replaced in terms of unit with meter, and as P is mass into velocity, mass can be replaced with kilograms, velocity can be replaced with meter per second, and the SI unit of angular momentum is given by kg meter square per second. This is the SI unit. Hence, as the angular momentum is a vector quantity, if it is a vector quantity, it will have direction as well as magnitude, and we defined both in our situation. Direction is given with the help of right hand rule, thumb rule, and magnitude is given by r cross p. In next chapter we will discuss about our different physical quantities which are related with the mechanics of a particle or with the mechanics of a system of particles.